Hello people, so today we'll be solving LeetCode equation that is 2458 height of the binary tree after subtree removal queries. And in this we are given the root of a binary tree with n nodes, and each node has assigned a unique value from 1 to n, and have we are also given a queries of size m, and we have to perform m independent queries on the tree, where in the ith query we do the following. We have to remove the subtree rooted at the ith node with the value queries of 5 from the tree, and it is granted that the queries of 5 will not be equal to the value of the root. And then we have to return an array answer of size m, where answer is the height of the tree after performing the ith query, and the queries are independent, so the tree returns to its initial state after each query, and the height of a tree is the number of edges in the longest simple path from the root to some node in the tree. For example, we are having 1, 4 and 5 and 7, so this will be the height of the tree. The height of tree comes out to be 4. I guess it's, oh okay, so 1 3, oh they are just considering the edges, oh sorry, yeah. So for this the height of the tree is 3, and in the queries we are just given 4, so we have to remove the subtree which is rooted at node 4, so this part. And after that the tree height of the tree is just left this, which is 2, so that's why 2 comes out to be answer. Okay, so first of all what we can do is we'll be finding the height from every node, and then it's just going to be pretty much easy to calculate our final result. Okay, and so for this let's have two hash maps. So map of integer comma integer, oh sorry, yeah, no, this will work, and let's call it answer map, answer only, so that is equal to a new hash map. And let's have a map of tree node comma integer to store the height, integer, let's call it height only, so that which is equal to a new hash map. Okay, now what we'll do perform a DFS on this. So starting from the root node, the current height is 0, and my current depth is also 0, and the maximum height or maximum value, let's say. Then we are having the answer map as well as the height. Okay, well, let's just quickly write this DFS function. So in this we are having a private, it's going to be a void only, private void DFS. In this we are having a tree node int depth, or oh I cannot name it, height. Okay, and int maximum height, my tree node, oh sorry, map of integer comma integer, the answer map, and also the map of tree node comma integer, the height map, height. Okay, and then the base case obviously, that if root is equal to null, I'll have to return, else what I'll be doing is I'll be traversing both the left and the right side. So dfs node dot left, and then depth will be increased by 1, and I'll be like the maximum height will be equal to maximum of my depth, current max, obviously max height comma depth plus 1, and the max plus the height of the maximum height, basically uh, node left comma node dot right dot left comma node dot right, and then I'll be passing in the answer map and the height map. Okay, similarly I'll call it for the right as well, so nothing much would change here. It will be just right. Oh, I made a mistake here. I'll be passing the maximum of the height of the node dot right, and the maximum which I'll be getting from the height map, and here it will be node dot left only, and here it will be the height map. Okay, and now let's quickly write this height function. So private int this cannot be cal height, yeah, this will work. Private int cal height, calculate height. Basically in this I'm having a tree node and the map of integer comma, oh sorry, tree node comma integer, which is height map only, Okay, and then firstly, if node is equal to null, I'll have to return -1. Yeah, and then I'll be checking that if height dot contains key of my node, and then I'll be doing a return height dot get node. Okay, else I'll be calculating my height, so int h, so that will be equal to maximum of height cal height with node dot left comma the height cache and comma cal height with node dot right comma the height cache, and then I'll be doing node dot height map dot height dot put just node comma h, and then I'll be returning height dot, or I can just return h as well. Okay, and most of the things are done. Now let's write the tree queries function, which is the main left. Let's have a int res, so that is equal to new int of size queries dot length, and then I'll be devising in each query. So for int I equal to 0, I less than queries dot length I plus plus, so result of I is equal to my answer map dot answer dot get queries of I. It's, yeah, and at the end I'll just return the result. Okay, now let's give it a run. Oh, tree node aware. Let's give it a run again. If node is equal to null, or run again. Cannot, because the return value is null. Okay, so how is this possible? At which line? Line number 26. Solution dot pre-query line 56, 56. Okay, not. Answer dot get query of 5 here. Did I make a mistake? Okay, I'll just. Okay, height is equal to 1 plus maximum. Now let's give it a run again. Oh, still. Oh, I haven't updated the answer map any time, so that was the major mistake. So answer dot put no dot val comma the current max height. Now let's give it a run again, and it works probably fine. Now let's submit it. Oh, a difficult question, 21, and it gets accepted as well. Okay, so this was for today. Thank you for watching.